We're going to look at this idea of integration using substitution. Mentioned it earlier, but now we're going to look at it in a bit more detail. We'll look at it again in extension 2 as well, but the difference between extension 2 and extension 1, in extension 1 they give you the substitution to use, and so your hand's sort of forced, you've got no choice. Whereas in extension 2, it's up to you whether you want to do it by substitution or not. Basic idea is we're trying to convert the integrand into a standard form. So something we know how to do. So let's just recap all our standard integrals. These are the ones that do appear on the reference sheet in case you do happen to forget or have a little mental blank. Okay, they have the derivative times the function to some power of n. And so that one we can just add 1 to the power over the power, and they just make the point that, well, of course, n is not equal to -1 in that case, because if it was equal to -1, what would you have? Yeah, it'd be a log, because you'd have derivative on function. Then they go through the trig ones. So derivative times sine gets minus cosine, derivative times cosine gets sine, derivative times x squared gives you tan. They have the exponential one there, so derivative times e to the function x is e to the function x. Then there's the log one. So derivative over the function is the log of the absolute value of function x. They also have the log one where the base is not e. And remember, the only difference there is that we divide by log a. Then they have the inverse trig one. They list it as inverse sine of function x. They don't actually mention that it could also be minus the inverse cos for some reason. And we have inverse tan. So they're the ones that appear on the reference sheet. So something like this. And, they've given us the substitution to use is 4x squared plus 8x minus 7. Now, had they not given that to us, then of course we're looking for, in this case, derivative on function, because the order of the polynomial on the top is 1 less than the one on the bottom. So you probably differentiated to get the top there. But all right, they've given us it. So there's u on the bottom right there, in case you didn't notice. du would be 8x plus 8 dx. Well, it's close. We've got x plus 1, so it's sort of du, x plus 1 dx, but actually it's 1/8. So 1/8 du on u. It now is in the standard form. Du on u, we know is log u. Substitute back in, and we get our log of 4x squared plus 8x minus 7. Okay, dx on x, log x cubed, let u equal log x. Now, if they had not given me that substitution, I'm usually looking for what's the function going to be, and it's usually going to be the function is going to be the thing to the power, is what we're going to use. So u is log x, so du becomes dx on x. We've got dx on x, so this becomes du on u cubed, which is -3 for the power. Add 1 to the power over the power, and sub the u back in. Okay, this one came from a couple of years ago. Well, 3 years ago now, isn't it? 2018 paper. They told us to use the substitution 1 minus x, which I suppose, had they not given that to me, might not immediately be obvious. That's the one that I would use on this one. Okay, so if du is 1 minus x, so du is minus dx, but we've got limits we need to sort out. So when x is -3, u is 4. When x is 0, u is 1. So let's set it up. What was du? Du was minus dx. Well, I've got dx, so it'll be minus that. U is 1 minus x, so underneath the square root sign, I'm going to have u. But then I've got this x on top. So if I rearrange what they've given me, x is going to be, move that one that way, 1 minus u, is that? I think that's what, yeah, move that around, we get 1 minus u. So we've got 1 minus u on root u du. I guess the advantage of doing that is now I can split that fraction up into 2 bits. I mean, when I had 2 terms on the bottom, I couldn't do that. But now I've got a single term on the bottom, I can split it up into 2 fractions. Notice I've also got rid of the negative there by swapping the limits. So now I'm going from 1 to 4. So the integral of 1 on root u is 2 root u. I've done that straight away because again, it's another one of these ones that occur a lot, and we will see it certainly in our extension 2 integration. But it comes from u to the minus a half. Add 1 to the power becomes positive a half over the power, so over half becomes times 2, so you end up with 2 root u. And the integral of root u is 2/3 u root u. So let's sub in. It's just a bit of calculation, and we get our minus 8/3. Okay, use the substitution, u equals cos squared. Yeah, okay, maybe that one's not immediately obvious either, but it's going to be one of the trig ones you would imagine. So u equals cos squared. Oh, this one, by the way, comes from 2019. Differentiate, bring down the power, lower the power, diff the inside, we get minus sine x. So minus 2 cos x sine x, now we see where how the sine 2x relates to this. Because I've ended up with 2, well, I've got it written as cos x sine x, but 2 sine x cos x is indeed sine 2x. So our du is minus sine 2x. So I've got the du there, just got to make it negative. And then I'm going to have 4 plus u squared. Work out our new limits. So when x is 0, u is 1. X is pi and 4, u is a half. So there is our integral. Once again, I've swapped the limits around and made it a positive. So the log of 4 plus u. Notice I didn't bother with the absolute value signs there, because when I sub those in, they're going to be positive anyway. So I didn't worry about it. Now, I think I mentioned this before when we were doing logs. I've taken the 2 lines to do it. But because it's a log, you could legitimately just say, well, it's the log. What do I get when I substitute in 1 over what do I get when I substitute in a half? Mind you, in this case, you're going to get a fraction on the bottom. It's going to take you another step. Anyway, so we get log of 10/9. 17, how interesting. I went 18, 19, 17. I wonder why I went in that order. This time you'll notice the substitution, u is not the subject, x is the subject. So x is u squared minus 1. Now when you are doing x equals function u as your substitution, you just need to be careful with your substitution of numbers, because just check that it's consistent with the domain of the original function itself. Because in this case, things like, well, x can't be -1 for a start. Well, it can't be anything less than -1, can it? But we're fine. Our limits are 0 to 3, so it's no dramas. We can certainly do this. So x is u squared minus 1. That essentially is the same as saying u is the square root of x plus 1, but mind you, positive square root. So it matches our question here. So dx is 2u du. Fix up those limits. So they now become 1 and 2. So let's see, what have we got? The x, what do I need? Oh, because it's in terms of x, I can just substitute straight in. I guess that's one of the advantages of making x the subject in the substitution. You don't have to really think about it too much. So sub it straight in. X becomes u squared minus 1. Root x squared plus 1 becomes u. And dx becomes 2u du. Tidying all that up, taking the 2 out the front, u squared minus 1. Add 1 to the power over the power. Sub in the 2. Sub in the 1. 8/3. 8/3. Okay. So substitution.